Hello and welcome, my dear students. Hope you are preparing well for your exams. So today I am starting this thermodynamic subjects. Before going to the subject, you should know some basic concept regarding this subject. So in this video I am discussing some important formulas and important theory to solve the problems. So let us start the today's session. Okay, before going to the subject, we should know about the thermodynamic system. Okay, should know about the identifying the thermodynamic system which is given in the problem. Okay, problem में system को identify करना रहता है. So let us see how to identify the thermodynamic system. Thermodynamic system. Okay, let us see. If in the questions they are given like this, rigid container, okay, if in the question they are given like this rigid container, so you have to assume or you have to treat like this is a closed system. Why this is closed system? See here properly, there is no entry of mass and entry and exit of mass and energy, so it is called closed system. And another system is called open system. Okay, if in the question they are given like turbine, compressor, nozzle, condenser, these all are flow devices. This is known as open system. You have, this is called open system. Okay, the formula for work done is different for closed system. The formula for open system is different. Okay, the another system is called isolated system. Isolated system. If in the question they are given like rigid container isolated with surrounding, rigid container plus isolation, then you have to assume like this is the isolated system. Isolated means Q is equal to 0. Heat interaction is 0. Heat means this is the form of energy, means there is no neither mass nor energy can cross the boundary. Okay, moving on to the next concept. So the next concept is universal gas constant and gas constant. Okay, gas constant R and universal gas constant. Sometimes some books they have given like R bar, or in some books they have given RU. Whichever like you can take. Okay, what is gas constant? In many problems you will use this gas constant. Okay, sometimes they will give the molar mass, and you already know the universal gas constant. This is the constant value which is 8.314, but the value of R is different for different gases. Let us see. The formula for this is Ru or R bar is equal to M into R. This is characteristic. So this is universal gas constant. This is the molar mass, and this is gas constant, and sometimes this is called characteristics gas constant. Okay, let us see how this is different for different gases. Let us take pen. Mm, okay, R bar is equal to M into R, means R is equal to R bar by M. Okay, the R bar is a constant 3.8.314 divided by M. Okay, let us take R for air 8.314, and what is the okay, what is the value of M? What is the value of M for the air? Let us see. What is the value of M? Let us. I have some standard gas molar masses. The value of R. The value of R is 29. So it's come like, see, calculate in calculator, and R for helium 8.314. The value of helium, the value of molar mass for helium is 4. Let us calculate in calculator. Okay, this is all about the characteristic gas constant, or sometimes it is called gas constant. Okay, in the question they have given, if the molar mass, you have to divide it by 8.314 divided by that molar mass, then you will get this R value. In question they have, sometimes they have not given directly this R value, they have given molar mass. This is capital M, molar mass. Sometimes they have given molar mass, so you have to divide this molar mass by characteristic gas constant. This is fixed value 8.314 kilojoule per kg Kelvin. Okay, next concept is, so the next formula, this is the very important and famous formula. It is ideal gas equation. Everyone know this formula, that is PV is equal to MRT. This is small m. Okay, but what are the units you have to take? See, this will always in kilopascal, and the volume, the unit of volume is meter cube, and the unit of mass is kg, and this is the gas constant or characteristic gas constant. The unit for this is kilojoule per kg Kelvin, and the unit of temperature is Kelvin. Okay, listen here carefully. If you take the pressure in kilopascal, you have to take R in kilojoule. If you take this pressure in pascal, you have to take R in joule per kg Kelvin. In problem, they have given R in joule per kg Kelvin, but in the question they have asked kilopascal. So I have to divide it by 1000 to convert it in kilojoule per kg Kelvin. Okay. Okay. The next concept is work done for different process. Hope you know all the formula, but I am quickly revising this all formula. Okay. So the first process is constant volume process. Sometimes this is also called as isochoric process. Isochoric, and isometric also. Okay, the formula for work done is 0. Okay, the work done, the displacement work is 0. Okay, you have to say like displacement work. Displacement work is 0. Okay, the another concept is how to find out this work done. Okay, one simple trick is there. Draw the PV diagram. For constant process, it will comes like this. Okay, the area under the PV diagram is known as work done. Listen here, the area under PV diagram on volume axis is known as work done. Okay, see, listen here, see here, the work, there is no area in volume axis though, so the work done is 0. See the next process, constant pressure process. For this PV diagram is like this, process 1 to 2 PV diagram. See here, what is the formula for work done? Area under PV diagram on volume axis. This complete area, if you find this complete area, you will get the work done. Okay, it is looks like rectangle. What is the area of rectangle? Length into breadth. What is the length here? V1, V2. What is the height here? P. So means P into V1 minus V2. Okay, if you multiply inside this, you will get PV1 minus PV2. Here the pressure is constant. So we can take P is equal to P1 is equal to P2. So P1 V1 minus P2 V2. You know the one formula, PV is equal to MRT. MRT 1 minus T2. So this is the formula for constant pressure process work done. Okay, moving on to the next slide. Next process is isothermal. Isothermal. The PV diagram is like this. Okay, listen here. If the process is go like this is the expansion process. Isothermal expansion. If the process is goes in reverse direction, then it is known as compression, isothermal compression process. Okay, what is the work done formula? Work done formula is P1 V1 ln V2 by V1, means P initial ln V final by V initial. Okay, next process is adiabatic process. In adiabatic process, Q is equal to 0. What is the work done formula? P1 V1 minus P2 V2 divided by gamma minus 1. Okay, we move on to the next concept. Okay, the next concept is the value of Q, means heat transfer for different process. Okay, heat transfer, formula for heat transfer for different process. Okay, let us see. The basic formula for is come from the first law of thermodynamics, that is dq is equal to du plus work done. Okay, and for the constant volume process, work done is 0. So that's why dq is equal to du. The formula for du is equal to mcv dt, means T2 minus T1. So the formula for change in heat transfer for the constant volume process, this is the constant volume process, is dq mcv T2 minus T1. Okay, the formula for constant pressure process heat transfer, what is the heat transfer? dq is equal to du plus dw. Okay, here we should take work done is there na, that's why we can take displacement work pdv. Here the pressure is constant, so we can take dq is equal to du plus dpv. Okay, we can take differentiation common here, u plus pv. Okay, the u plus pv is equal to h, that is enthalpy. Next slide, we can take next slide. Okay, where we left dq is equal to du plus dpv. Okay, dq is equal to du, you can take common u plus pv. Okay, u plus pv means h. So the change in heat transfer is equal to change in enthalpy. So the change in formula for change in enthalpy is mcp T2 minus T1. Listen here. So the constant pressure heat transfer formula is mcp T2 minus T1. You have to remember this formula. Here also you have to remember this formula. Okay. Next process is which process? Gas adiabatic process. In adiabatic process, Q is equal to 0. That's why there is no formula for Q heat addition, because heat addition is 0. But we can write like this also, dq is equal to du plus dw. If the dq is 0, means du is equal to minus dw. Okay, sometimes in question they have given temperature. Okay, the formula for this is fix mcv T2 minus T1, and here minus of T1 V1 minus P2 V2 by gamma minus 1. Okay, this is, you can use this formula for finding mass. Sometimes they have given initial temperature, you have to find out the final temperature. They have given all these pressure and volume value. Okay, this is the adiabatic constant. Sometimes it's called gamma also. The value of gamma for air is usually 1.4. This is different for different gases. Okay, the value of gamma for triatomic gases is 1.33. Okay, the value of gamma for air monoatomic gases, air is monoatomic gases, that is 1.4. The value of gamma for inert gases like argon, helium, these are diatomic gases. For diatomic gases, the value of gamma is 1.66 or 1.63. Okay, remember this gamma value. Okay, if in the question they have given like argon is expanding in cylinder, Don't take as 1.4. That is wrong. Okay. Next, the next concept is, okay, one more process is left now. What is that process? Polytropic process. Polytropic process. The work done formula for polytropic and adiabatic same, but the heat transfer formula for polytropic and adiabatic is different. In adiabatic process, remember, listen here. In adiabatic, the value of dq is equal to 0, but in polytropic this is not 0. One formula is there. dq for polytropic is equal to gamma minus n divided by gamma minus 1 into P1 V1 minus P2 V2 divided by n minus 1. Okay, remember this formula. Many of students neglect this formula, but don't neglect. Sometime asked this heat transfer in polytropic process. They assume like a heat transfer for polytropic process is also 0, but this is not true. Okay, the next concept here is van der Waals gas equation. Okay, before going to the van der Waals gas equation, we should know some Cp and Cv value for different gases. Okay, hope you know, everyone know this formula. Cp by Cv is equal to gamma, and Cp minus Cv is equal to R. Okay, here one more formula is there. Okay, Cv is equal to R by gamma minus 1. Okay, but we know that formula. What is R bar is equal to M into R. So the R is R bar by M. We can replace this R bar by M. Cv is equal to R bar by M gamma minus 1. Okay, let us see for the value of Cv for air. Value of Cv for air. This R is constant 8.314. The value of molar mass for air is 29, and the gamma for air is 1.4. If you put this value, you will get 0.718 kilojoule per kg Kelvin. See, sometime in the question they have given molar mass. That is molar mass. They have given molar mass. You have to find out the Cv value. So this is the formula. What is that formula? Cv is equal to R bar by M gamma minus 1. Okay, this is an important formula. Many of students don't know this formula. Okay, next. If you know the Cv, then you will get Cp by Cv is equal to gamma. If you multiply by gamma into Cv, you will get Cp. Okay, and one more, we will take another example for Cv. For helium, R bar by M gamma minus 1, 8.314 divided by 1.67, because this is the value of gamma for helium. This is the diatomic gases, so you have to take 1.67 or 1.66. The value, find out this value. The unit is kilojoule per kg Kelvin. If in the question they have given helium expanding in cylinder or something, some device, some thermodynamic device, you have to find out Cv like this. If they given molar masses, otherwise you have to remember this molar masses. Okay, next what you discuss? Van der Waals equation. Okay, so the next concept is van der Waals gas equation. Okay, I noted down one side. I will discuss this van der Waals gas equation neatly. Okay, P plus A by V square into V minus B is equal to MRT. So this A and B are van der Waals constant. Okay, you have to remember another one formula, work done for this process. Okay, I noted down one side. Okay, I will give you work done for van der Waals gases. Wait for 1 minute. Okay, here the van der Waals work done for van der Waals MRT ln V2 minus B divided by V1 minus B plus A divided by 1 by V2 minus 1 by V1. Okay, sometimes they will ask directly this formula, or sometimes they will ask in MCQ. Work done for van der Waals formula directly. You have to remember this much only, okay, for van der Waals equation. Okay, this is all about the today's session. Okay, some more concepts are remaining. We will discuss in next video. Hope you enjoy this session.